So let's get started, because as I mentioned, like we have to cover a lot of things. And if you really want to get started in fuzzing and just wanted to know like what the white box fuzzing is mean, what it's all about, then the coming 2 hours is all yours. Enjoy, and please feel free to ask questions. We have a Slack channel. Probably I can answer all those questions when I'm done with the workshop, or I can parallelly go on, just toggle and answer a few of the questions, but don't worry, I'll try to answer all the questions. Before we get started, this is something about me. My name is Dhiraj Mishra. I work as a senior security consultant for a company called Cognosec, based out in Dubai. I tweet at random Dhiraj and blog at inputzero.io. So you can buzz me anytime on Twitter or on the email if you have any doubt or any questions related to fuzzing. Moving on, what fuzzing is, like this is a success mantra which I have been telling to most of the people when I take workshop or training. So post this session or workshop, if you go back and start with fuzzing any software, and probably when you don't get any crashes, have patience, because fuzzing softwares may take a lot of time. So you will require patience in that. For example, if you're fuzzing any software that might generate a crash in 10 minutes, probably few of them may generate a crash for 6 months, or some of them might take an year. So hold on. So that's what the success mantra is. Just let it fuzz. And I'll just share you the different tips and techniques, like how to get quick crashes and so on and so forth. So most of the people come back to saying me that, hey, dude, what would be the maximum system requirement which you can give to a fuzzing system? Seriously, like we can have a lot more, but the minimum would be at least 4 GB of RAM with any Ubuntu or Debian based system, with at least a minimum 40 GB of hard disk. So that's what the minimum is. You can have a rack or a server at home or somewhere where you buy it. So it's up to you. Like you can have 200, 250 cores, cores, so basically, so it's up to you. But the minimum is something like 4 GB of RAM and 40 GB of hard disk space.
Okay, Dhiraj, wait a minute. The link is no longer available. Maybe we need to put a new one for the LAC. It's no longer available. Maybe they have like time opening. I don't really know, but we need it again so the people can enter there.
The link is same, probably. I'll just give me a moment.
Okay.
That is because it's bad copied in the chat. Está mal copiado el link.
Okay, perdón, ahora nos fijamos, nos lo mandó al principio, pero como no había nadie, tenemos que volver a mandarlo un par de veces durante la charla. A ver, fíjense si ahí va. Fíjense el de recién.
Are you guys able to join now?
Wait, the problem was that we miscopied, so we tried a new one.
Yeah, okay.
It works.
Okay.
It works? Okay.
Yes, it works. You can continue. Sorry for the interruption.
That's okay. So yeah, that's the minimum requirement of the system. Moving on. So yeah, that's the password for the Ubuntu OS, which I have been provided. I know it's just simply party. So you can log in, and then we can start with all the things which we are going to do. So username is 0 and the password is PARTY. Everything is in small. So you can just unlock the system using this password. The provided Ubuntu OS is of minimum 40 GB of hard disk, and it takes 4 of your cores. So that's the minimum which I can give, and it's a minimum requirement when you start with fuzzing. So what's the agenda? Not to get bored. I understand it's very breezy morning at your end. So it's like not to get bored, have a coffee, sit, relax. Please feel free to ask questions. And we'll be fuzzing a lot more things in coming 2 hours. So why fuzzing is required? Like, what's fuzzing? Why it's in place, and why it has been given so importance right now in current downtown situation? Because if you remember back in 2014, there was a vulnerability called Heartbleed, and that vulnerability was basically identified while fuzzing that specific instance. And it was nothing, just a heap-based buffer overflow. So the idea to showcase this slide over here is, when you start with fuzzing, so you remember like the Heartbleed was one of the most common and the most hype bug at that specific era back in 2014. So when you start fuzzing with certain SSL protocols or so on and so forth, you may end up getting certain bugs which are similar to Heartbleed. So that's the reason we are here, to understand what's the need of fuzzing and how we can do it. Yeah, so moving on, let's get started with AFL. Now, this is just to give you a quick idea about what AFL is. AFL is known as American Fuzzy Loop, developed by Michael when he was working back in Google. He recently shifted to Snapchat as a security director. So AFL is a mutation-based fuzzer, and it's an input-based fuzzer. So you provide an input, and it mutates that input, and then it fuzzed it. And it is also known as coverage guided fuzzer. And I'll let you know why it's known as coverage guided fuzzer. Before AFL, it used to be called as Bunny the Fuzzer. Michael named it as Bunny the Fuzzer. And then further, it was renamed to American Fuzzy Loop. So that's a quick overview what AFL is and who created. So many thanks to Michael for this. Moving on. So this is a very high level approach, which I tried to paste on a single slide, like how AFL works in general. So let's suppose you have a binary and you instrument your target. Now, target is like a binary, open source software. When I say the word instrument, it's like AFL Go. When we compile any technology or any application from AFL, it goes to certain endpoints, and we don't use the general compiler of glibc or libc, which is GCC. We use some other library, we use some other cross compilers to compile it. So when we compile it, basically it instruments your target. So that's first part of when you start with fuzzing. Then we provide a proper input file. Now, when I say a proper input file, like let's suppose a scenario where you have a ELF file which takes .xml as an input. So we have to be very specific to pass only .xml as an input. So we cannot pass .txt or .doc or something else. So AFL is very specific to what input has been provided. So it can render the input properly and then mutates it further. So when input is provided, AFL goes to the third stage, which does a mutation or the mangle of that test cases. Now, I'll let you know how it does it and how it performs it. The starting coming slides, 15 or 10 minutes would be more theoretical, because we need to get a clear picture of or the understanding of how AFL works. So please hold on with me. So when third stage has been completed, it executes the compiled binary with the mutated test case, and then we can analyze it in the output directory. So that's a very generic idea about how AFL works. We target a binary, we compile a binary, we specifically provide certain inputs which are part of or which is accepted by that software or application. Then when we start with fuzzing, it mangles the input which we have provided. When I say mangles, it's like it mutates the input, and then it takes the mutated input to the software and see how software renders it or react to see whether is there any crashes or not. So this is a very quick overview of how AFL mutates the inputs. Like for example, if you have a hex value of any input which is 48, 65, 6C, 6C, and 6F. So when AFL start mutating those input, so randomly it becomes from 48 to 68, from 65 to 65, 6C. It always change flips and bytes of every input. So it tries to do, it has a different 7 to 8 methodologies to mutate the input. So it keeps changing and flipping the bytes. So there's a GIF of this specific screenshot on the mentioned reference. So I can share the slides. You can see how it flips and how it changes the mutation of a input file which we passed. So yeah, moving on, we will understand the entire overview of how AFL works very quickly so that we can wrap this and go on with the fuzzing. So there are some color codings over here. We have red, magenta, yellow, blue, green. So when we have red, yep, that means we are getting some progress. It's a crash or it's not, it's very slow, or do we have any wrong syntax? So I personally feel that we should always target to see whether we have any red color indication on our AFL framework or not. So it can be good or it can be bad. So for in this specific instance, it is good because it has generated 28 unique crashes and 2,248 crashes overall. So yeah, so similarly, we have magenta, yellow, blue, and green, which is very self-explanatory. But personally, let's focus on the red panel or the red color indication from the framework. The process timing. Now, what process timing is, basically this specific part of AFL gives you understanding of how your AFL has been running, from how many days, from how many time, what was the new path discover. When I say new path, like for example, if you have input A, and when it passed to AFL mutation, it becomes an input B, and that input B is capable of crashing any application which we are fuzzing. So that's actually a path which AFL covers. So it gives you idea about the runtime, the last new path, any unique crashes or hangs. So this is the process timings which you have to take a look. That's that specific block which I have marked. Moving on, we have overall results. So it's very important, this part, because the very first thing which you see over here are known as cycles done. So AFL has 7 to 8 mutation. When it completes all the mutation and there is no pending path, like if AFL understand this, oh, now there is no path like left, so one cycle is completed. Just make sure that when you fuzz any application, you complete at least one cycle. So that's a very general practice. So over here, you can see it was 4 cycles, which is fair enough. I can just simply stop it, but never close your fuzzing instance when your cycles done is 0. It means that your AFL still have jobs to do. It may still crash the program with the input provided over here. And then total paths discovered 340, unique crashes 28, and unique hangs 0. We will be focusing more on crashes, not much on hangs. Cycle process, again, it gives you an idea about the current test cases. I can give you a quick overview when we start with what the test cases in and how it is being queued. So AFL has a folder where it queues all the mutated input, and one by one, it start sending those inputs to the application software or in the framework to fuzz. So this is just to give you idea about like 338 current test case was been running. You have a coverage map over here, like when certain coverage has been observed, the new instrumentation has been observed, it gives you a details about over here. That's pretty much which we can ignore currently right now. We can see it later. Staging progress, again, it's one of the core focus which we need to identify. Now you can see over here, it says that now trying arithmetic 8 on 8, and total execution speed is 1.5 M, and execution speed is 3,615 per second. So it means that I'll get back to this one on the coming slide. This is something which we need to focus. It means that the input which we provided, it is mutating input and passing it to the software. Like it is generating almost 3,615 test cases per second and fuzzing that specific application. So the always focus, if you are a fuzzing guy, always focus for the execution speed. If your execution speed is slow, probably you will have crashes after 6 days or 7 days or so on and so forth. If your execution speed is high, that means you have more, because the framework covers a lot more test cases per second. So here it is covering actually 3000 XXX test cases per second. So this is fair enough. Generally, okay, so generally it would be what you can say, 200 to 300 test cases per second, just make sure that your framework doesn't, your execution speed doesn't go less than 100 or so on and so forth. Then that's something which you need to work on. So again, this is pretty much self-explanatory. It says that what's the favorite covered paths, what the total crashes, was there any timeout? So what happened when I say timeout is, it goes with a certain test case to generate a crash, but somehow the application gets hang. So that's why it has been said that like total timeouts is 1. And when we say total crashes, it says 2,248, but the unique is 28 only. So always focus for the unique crashes. We would not prefer the rest of the crashes because might be AFL is targeting certain similar functions again and again, and that's the reason the crashes has been recurring over here again and again. Again, this is the fuzzing strategy. We will discuss this in the other slide because you can see it has a bit flip, byte flip, arithmetic, known ends, dictionary, havoc, and trim. So similarly, there are certain sort of fuzzing strategy which AFL used to mutate the input, and it's the actual core of the AFL framework. Again, the path geometry is similar like levels, like you have initial test case, whether there are any pending favorite path. So when pending becomes 0, your cycle would be 1. And if you have pending is 129, it will keep on fuzzing, keep on fuzzing. So just make sure that pending or pending favorite should be 0, then you stop the fuzzer. So that's pretty much, you have fuzzed the entire application well and good. So yeah. Stability is like how stable the fuzzer is while fuzzing the target binary. So over here it's 100%. Like few major or the what you can say comprehensive software such as Vim or like you can say curl or TCP dump, they are very huge software, and when they start with fuzzing, so maybe AFL when fork the server, it might not be stable, which is fair enough. Just make sure it doesn't go much down, like more or less than 70% or 60. It can be 80, 85, 84. That's fair enough as per my knowledge. This is pretty much straightforward. Like when you start with fuzzing, it's all about cores, and this is the CPU utilization which you can see. It's 86% over here. It can be overloaded when it goes to more than 100%. So just make sure that it doesn't go to 100%. If it is, that's okay, fair enough, because even you are fuzzing, so that's okay, that's totally fine. Most of the complicated software takes more than 100%, so it's fair enough. So yeah, that's what the strategy is. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 strategies which AFL covers. It has calibration, trim, bit flip, arithmetic, interest, extras, havoc, splice, and sync. So for example, when we say havoc, it says that various tag-based operations. So it basically when the inputs are being mutated using havoc, it goes ahead and uses the when it changed the operations under the stack of the input, and at that time it uses havoc. So over here, if you see, currently it has used bit flips, it has used arithmetics, and so on and so forth. It has used havoc, it has used trim. So this is the actual core strategy of AFL, and these are the mutators which mutates the input when we start with fuzzing. So I hope that's pretty much clear. This is just to give you and clear you the basic idea of how AFL works. So that was very much necessary to have understanding on all the blocks. Here are a few of the utilities which we will be dealing with. We have AFL GCC, which is a replacement of our normal glibc cross compiler, which is GCC. Similarly, we have Clang, we have AFL Fuzz, Cmin, got CPU, and so on and so forth. We'll be dealing few of them in the coming slides. We use CC for changing the cross compilers. We use CXS for changing the secondary cross compilers. When any programs has configure is responsible for checking the build and the binary and the required dependencies when you configure any program. Disable shared is very important when you fuzz certain binaries which have most of the shared libraries. So just make sure that you disable shared libraries. you have make file to generate or to create make. Similarly, we have CMake list, and we will be dealing this with @@, and we have to do echo core proxying kernel core pattern, because when we fuzz and AFL generates a crash, so Ubuntu or Debian based system have a very bad habit to give a pop-up saying that this program was crashed. So we run this as a su or the sudo privilege just to make sure that we don't get rid of it. We don't get any pop-ups again and again. So that's why we do that. So here are some prerequisite. We have sudo apt update, sudo install clang, sudo gcc and gdb, and so on and so forth. So that's a very basic prerequisite. But during my fuzzing journey, I have seen that most of the people get rid of when they have a dependency issues. So probably I have created a pack.sh file which has most of the common libraries which you can use for fuzzing most of the applications out there, and you won't get any dependencies issues. So dependencies are something which you can say they act like an enemy for us when we start with fuzzing any binaries. So how to get started? You can simply do apt get install AFL, or you can just go to this website of Lamcoft, which is actually the Michael's website. You can download the AFL latest, just do tar make and sudo install, or you can go to the actual repository at github.com/google/AFL. I know what you must be thinking, like I have been talking for more than 15 minutes. So let's get started with fuzzing. I just want to make sure that my audio is audible. Were you guys able to hear me clearly?
It's lagging a little bit, but it's good. Like sometimes you just lag a little bit, but it's pretty good.
Okay. Yeah, let's get started. So that's the VM which we have shared, and you can just simply log in using party, PARTY, and just open your terminal. I have created a folder called fuzzing. You can navigate over there. I'll wait for like few seconds before I do any other activity, because I want to make sure that you guys are with me. So once you are inside the fuzzing folder, right now let's go to folder called libwave. And in libwave, you will find another folder called tools. Let's go to tools. Then there are two other folders, wave gain and wave info. Wave info. So let's go to wave info for now. Let's do ls. Now you can see you have a C file and a make file. So when you see cat make file, it's pretty much clear. It uses CC as a normal cross compiler, like it uses the glibc like normal GCC compiler, and then it compiles this wave info.file. So now guys, if you just simply do make, because we already have a make file, so there's no configure. You have to whenever you have a make file, just simply do make. So when you make this and do a ls, you will have a binary, which is wave info, right? But over here, it compiles the binary with GCC, which is the standard binary, which is the standard cross compiler for the Debian based systems. This won't work when you start with fuzzing, because we are fuzzing an open source software. And if you recall, we need to instrument those binaries. So you just simply do make clean and do ls now. It should be back again, make and wave info.c. Just do make clean so that the binary which was compiled would be deleted. Now you can do nano make file. You can go to GCC and just simply make it AFL-GCC rather than GCC, and save this file. If you see previously we had GCC, it to AFL-GCC, and now we make the file. So when we make it, basically you can see the compiler difference. So over here, it was basically just compiling using GCC, and over here, it instrumented the AFL binary. right? So when you do, again, it will have wave info, but it would be compiled by AFL GCC. So if you do wave info, it says that it required wave info and file name. So as I mentioned previously, AFL is a input based fuzzer. So we need to pass an input to fuzz any application or a software. So what does this file, like, for example, it's very maybe self-explanatory because it says wave info, you know that we have an extension called .wave. So this file will only take input which has the extension called .wave. So what you can do is you can go to ls corpus directory. So if you go back three directories back, you will see that I have created a directory called corpus, and it has a sample wave file and few other test cases. So we will be focusing on sample wave file for now. Just do cp corpus sample wave file to this present directory, right? Now when we do wave info sample, it gives an info file, this sample wave file, right? So just to give you an idea, if we would have passed ps dot, maybe, I'm not sure, but maybe it would haven't worked. So let's see wave info and do ps. You can see couldn't open the file. So be very specific when you pass certain inputs. So if it requires wave file, just pass wave file. So we'll do ps, right? So wave info sample.wave, right? So let's create a directory mkdir in for input and mkdir out. Just do cp for sample wave into in. Just copy your sample wave file to input folder. Sorry. If you run, go to this.
Dhiraj, sorry, you should check your internet. It's not really working. We can hear you. You're lagging a lot, and we can hear you.
Oh, okay. So it's lagging a lot.
It was lagging before, but when I was going to tell you, you just it went well, but it's lagging again, and maybe we're missing some parts. I don't really know because I don't understand much of this, but you're lagging, so maybe you can.
Just give me a moment, I'll check. Just give me 2 or 3 minutes, I'll check it.
Okay.
Am I audible?
Yes, you are.
I'm sorry for the trouble. Just let me know again if you cannot hear me or if you cannot see any of my screen.
The screen is working well. The audio is lagging a little bit. Just that. Like the screen is working well, we can see it well.
Okay.
Always.
Okay. Just let me know if it still doesn't work for you.
Okay, I'm gonna be.
Okay, no, I'm sorry for this. Okay.
It's okay. You can continue.
So yeah, we'll just remove RM sample wave. So okay, we have an input directory which contains sample.wave file, and we have an output directory which has nothing, and we have our binary which needs to be fuzzed. So what we can do is, now if we do wave info in sample.wave, you see it's working fine. So it gives me the header of a specific sample wave file, right? So just cross check whether your compile binary is being working perfectly with the passed input. So that's the very generic idea. So if you do wave info in sample.wave file, it's working fine. So that means that you won't get any odd syntax check. So when I say odd syntax check, that means AFL should also get a proper syntax while fuzzing, right? So that's all we have got so far. So what we can do is AFL fuzz -I, and we'll AFL fuzz is for fuzzing the binary. Then we'll do -I, and then we do in, we pass the input folder -O for output. And this hyphen is just to give space, and we can just do wave info, the binary which we need to fuzz. And then we do @@. Now let me clear why we require this @@. So when AFL, you are saying that, hi AFL fuzz, here's this set of input file, and whatever output is being generated, send it to out directory. You have to fuzz wave_info. And this @@ is basically a pointer which points back to the input directory. So it's like when AFL starts with fuzzing, it takes all the inputs generated or being kept in input file, and it passes to this specific area. So that's why we put @@. And now we do enter. So as I mentioned before, we will get this error. And for this, just simply copy it. Go to a new terminal. You can do sudo su. The password is same. You can type party and paste it. Right? You need to do this because it doesn't display the standard Ubuntu generic crash or something. So that's fine. Let's do it again. AFL fuzz -I-O wave info @@, and start the fuzzing. So here it says some test cases are huge, and we'll get back to this, why it was huge. We can have a look on this. It started with fuzzing. You can see it has 4,000, or then again it goes to 30, which is bad. Then again it goes to 4,600. I hope you guys are till here. The command which we did was AFL fuzz -I in -O out wave info and @@. So it's been 37 or 38 seconds, and we initially got one crash, which is fair enough. Let's wait for a few more. Till then, I can have a look on Slack, whether we have any questions or not.
¿Alguno necesita la traducción? Porque me pidió que les traduzca y que les diga que pueden hacer las preguntas en el Slack para cualquiera. What's the root command you just?
Okay. So it was this.
Es el que tira el error.
It's the one that it's turning back an error.
Yeah, that's the reason we are getting error. So it generally gives an error because when we fuzz, we get certain crashes, and Ubuntu gives you a display of crashes every time. So just to ignore that, we do sudo su and run this command as a root so that we don't get that pop-ups from the Ubuntu box. Okay, so there's a question on Slack. It says how I know when to stop fuzzing. So you can stop fuzzing when your pending favorite becomes 0 and your cycle is more than 1. So you can stop fuzzing. Then just have a look on your pending favorite path. When it is 0 and you have completed your cycle, then I think it's good time to stop your fuzzing. Just to give you an idea, we ran AFL fuzz -I, the input, -O, the output, and the wave info with @@. So if you would have fuzzing it for more than 3 minutes or so, you would have find 2 crashes.
I have a question.
Yeah, please.
When you try that command, it throws an error that says, try again, the fuzzer need 1 or more to start with.
Is this something which you get the error, like similar to like this?
No, it's not similar, it's another.
By any chance, can you post the screenshot on the Slack group, please?
Okay, but I'm translating the question of another guy that is in the chat.
Necesita ayuda para las traducciones, yo estoy acá para eso. Si ustedes necesitan ayuda, avisen.
Yes, yeah. And the error says that the fuzzer need 1 or more test case to start with. Ideally, a small file under 1 kilobyte or so.
Oh, okay. So just to give you an idea, like, do you have a sample.wave file in your input directory?
Okay.
Yeah. If you don't have a sample.wave file in your input directory, you can just simply copy this from the fuzzing folder, or you can just copy it from the corpus, and you will have a sample.wave file. You can simply copy it on the in folder, the input directory which we created. So we have 4 crashes, but it still says that pending favorite is 1, but the cycles are done is equal to 1. So again, it's fair enough. We have 4 crashes. We can stop the fuzzer here. We can simply do Control-C. Am I audible well before than it, or it's still the same?
It's good now.
Okay. Yeah, so we have four unique crashes over here. So when we do ls out, you can see you will find certain folders such as crashes, hangs, and queue with some other data. If you recall, we just simply created an output directory. We didn't add anything in that. So if you do ls out crashes, you can see there are 4 test cases, 1, 2, 3, 4, which can create a crash to this specific wave info binary file. So just have a look. We can do .wave info out crashes. It has a, what you can say, it has a nomenclature, like for example, it has 0, 0, 0, 0, 0. Then you can put 0 and tab. So this indicates the SR number of any corpus, like it can be changed to 1, 2, 3, and 4. So we'll start with 0 first. And when we pass it like this, we hit enter. It says couldn't open the file, but it doesn't give us any segmentation fault or crash. So this might be false positive. Just have a look on the other one, which is 0, 0, 0, 0, 0, 1, and hit tab and hit enter. You see, you get a segmentation fault. So we fuzzed this binary for almost 5 minutes. We got 4 crashes. The command which we used was AFL fuzz-in-o wave info with @@. So I hope you guys are with me. So like in my case, 0001 is generating a crash. Maybe for you, it would be 0003, 4, and so on and so forth. So if we simply see cat out crashes ID 1, it's some sort of certain data which is causing the crash, right? So if we do cat out crashes ID 2, tab, enter, it's again some malform data, right? So what we can do is we can do GDB wave info. We can load the binary into GDB, right? Then we can do R, which stands for run out crashes, and we will copy this. And hit enter. You can see it gives a segmentation fault. Now segmentation fault is generally when the program gets crashed. And when we do BT, which is generally called as backtrace, and we hit enter, it says that in print info, in wave info.c, line number 18 is causing the crash. So if you go back, you do ls in wave info.c, when you do nano wave info.c, wave info.c, it says print info is responsible for getting this crash. So you can see this is something which is been generating the crash. Print info, print could not error, wave info file format. So you can see line number 28 at waveinfo.c is generating the crash. So this would be really helpful for developers as well out there who are attending this. So probably when you generate certain crashes, you can go back to your code and have a look where at which line and what was getting crashed. Over here, the root cause of getting crash was the malform data which the input has, like this data. This cannot be printed properly in wave_info, and that's the reason it is causing the crash. So you can see it says format print wave format. So that specific argument is responsible for generating the crash. And from here, you can go ahead and start with your debug analysis, whether it is exploitable or not. But that's the generic idea. I hope that's clear. We just do wave info out crashes ID to 2. It doesn't give us the crash. We go to 3. It still don't give me the crash. 4, there's no 4. So in my case, the test case number 0002 generates a segmentation fault. Or 0001. Right, I'm sorry, it's 0001. So maybe in your case, it might be something else. Just to give you a quick overview again, we did GDB, wave info. We loaded wave info into GDB. We did R, which stands for run, and we passed the command, which is out crashes ID, the input ID, which is actually generating the crash. And when we do a BT, which is backtrace, it will tell you what causes the crash at what line number and what else. So now you can see over here, depending upon your architecture, whether your RIP or EIP can be overridden to gain a code execution in this specific wave underscore info. I hope that's pretty much clear. It was a very small, sweet exercise just to get started with the wave info. It's there in the slide as well. So don't worry about the commands. If you want, even I can share a list of commands, what we used in our workshop and how we did it. We clone it, we change the make file, and we compiled it, and then we start with fuzzing. Now, if you recall, we had this error too, saying that some test cases are huge than 343 KB and so on and so forth. So we can use AFL cmin for this. Now what AFL cmin is, let's do ls, let's do rm-rf out. Let's clear the out directory which has a tons of crashes. Create a new fresh out directory, and do AFL-cmin-i for in -o, like a new input directory. And then you can pass the part to the binary or just the binary name. So it's like wave info @. So now AFL cmin is a utility which helps you to minimize the test case. So if you see this error, this one, it says that some test cases are huge. Look this txt file for the tips. Now the tip would be to minimize the test case. Now how to minimize the test cases? You can use AFL cmin -i in -o. -i in because we had a sample wave file in input directory. -o -new input because the new input which will be created would be in this folder, and then wave info. And if you hit enter, it says testing this, found this, and it basically minimizes a few of the bytes from this test case.
La página legítima para que ustedes no sospechen nada de lo que pasó, pero mientras tanto los atacantes se quedaron.
Right. So we have a minimized sample wave file now, which you can parse and generally fuzz it. So this is just to give you an idea that you can minimize your input file using AFL cmin. So AFL cmin is a utility, then -i for input, -o for new output or new input directory, then part to binary, attribute. I'll tell you what attribute is, but in this case, you have to simply do wave info and then @. So what it does basically, it takes few bytes of data from sample.wave file.
Excuse me, can you hear me?
Yeah, please.
I have an error when try to execute this last command, and the error says what info doesn't appear to be instrumented. I don't know if I have to do something extra, or I don't know what happened.
So it says, if you read the error, it says that the binary or it is not been instrumented. So if you go back when we started, so okay, just give me a moment. What you can do is you can do nano make file, just change your cross compiler to AFL-GCC, or just make sure it is not just GCC. It should be by default it would be GCC, but we change it to AFL-GCC.
Okay, perfect. I will try this. Thank you.
Yeah. Okay. Yep. So I hope it's pretty much clear over here. Right. We did the triage as well. So we also analyzed that print info is the actual function which is causing the crash in wave_info.c file by debugging it from GDB. So wave info was one of the very small program, right? So let's go back to the fuzzing directory and just go to binutils. So this is the latest version of binutils 2.3.5. So I'll be very slow, crisp, and clear over here. If you have any doubt, just let me know. So we have binutils. What we can do is, you can see we have configure file over here. We have makefile.def.in.tlp, but we don't have normal makefile. So we directly cannot make it, right? It says no target specified and no makefile found. So we have to configure it first. And if you recall, what configure mean is generally configure creates the makefile and the dependencies, it resolves everything. So what we have to do in this case, there is no makefile, so we cannot edit it. So you have to change the cross compiler over here, which can be done using cc equals afl-gcc and cxx equals afl-g++. So we are saying that our cross compiler should be afl-gcc and our secondary cross compiler should be afl-g++. Fair enough. Now we can do configure, right? Let's hit enter. I hope you guys are with me. Just navigate to fuzzing binutils 2.3. This is the latest version of binutils right now. We found that there's no makefile, so we have to create one. So we go to change our cross compiler like cc equals afl-gcc, cxx afl-g++, and then configure and hit enter. Now, if you see over here, it says that creating a makefile. Perfect. Now we have a makefile. So when we did cc, basically it changed our environment env. If you see environment variable, there must be change of a cc program. Okay, it doesn't matter. So once you run configure, you have a makefile. Just simply go ahead and do make-j4. Now when we do make, we are making it, and -j is for number of threads which we are utilizing. So let's do make-j. Don't forget to use a cross compiler called afl-gcc and secondary compiler to afl-g++. Configure it. Post configuration, just do make-j4 and hit enter. Now binutils is one of the most common and huge software which is being embedded into most of the common Debian based system. So it would take a little bit of time to compile it. Till then, if you have any questions, I can quickly check to my Slack channel. Like, please feel free to ask questions.
Y si alguno tiene una pregunta en español y necesita ayuda, reitero, estamos acá para eso. Para que no se sientan cohibidos si la tiene que decir en inglés, la dicen en español y los ayudamos.
Hope I am audible. There should be no problem. Okay. Just to make sure that your makefile should have instrumented the binary. So if you are compiling with the same step which I have did, you will find out the same, what you can say, the texture which you can see it on my terminal, and it was being made successfully, and it says that living directory, so on and so forth. I'll wait for a few more minutes, few more seconds basically. So what we did was we configured it first using afl-gcc. We then did afl-g++. We configured this, and furthermore we did make-j4. I'll just simply write down the command over here. We did this, and you can use semicolon space make hyphen J4. This was the command which we used. Okay, so there's a question on Slack. It says that we are getting the same file after cmin. Now, what happened is because we have only passed one corpus, which is one input file. So that's the reason even AFL is not able to filter out, or AFL cmin is not able to trim the input. So AFL cmin works more perfectly when we have more than 1 to 2 files, like 3 or 4 files. So it narrowed down 3 to 4 files to one single file. So maybe in this case, we were just simply using sample.wave, which is a single file, and he was not able to trim it more or remove the bytes or data. So that's the reason we are getting the same file. So if you add more sample file, you will see the changes. Okay, so there's another question which says that I got lost in the point. What is the make for? Okay, so what happened is, in general, configure is a file which checks for dependencies, which checks for build, version, system requirements, and so on and so forth. And this configure file creates the make file. And when it creates the make file, and when you make it, basically you are making a binary out of the source code. So when I do ls binutils right now, you can see there are obj copy, obj dump, you have read elf, you have strings, you have sysinfo. So this, when we do make, it creates a binary from the source code. So that's why we do make. Perfect. So if you would have done something like this, C equals AFL-GCC, then AFL-G++ configure. After that, you do make -J4. And if everything is perfect, you can do ls binutils. So when you do ls binutils, you should be able to see binaries such as address to line, AR, BD, BFD test2, obj dump, libtool, read elf strings, and sysinfo. Right? So now what we can do is, again, let's create an input directory, mkdir in. Oh, sorry. First, we will go to binutils folder. Now do ls to pwd. So I'm inside home, 0, fuzzing, binutils. And now if we do ls and do mkdir in, mkdir out. So in general, let's keep a practice that we have to create an input folder and an output folder. So let's do cp ... Let's go to the corpus directory, fuzzing, corpus. There are 3 files, sample.wave, which we have used already. Let's use this ps file. Let's do ps to this directory, or to input directory, right? So now our input has a file called ps. I hope you guys are with me. What we did is, we went to binutils folder, we created mkdir in, mkdir out. We copied the corpus, specifically the ps file, not the wave file, because if you have, if you go back, if you don't pass the necessary file which needs to be fuzzed, your AFL fuzzer won't work. So we did corpus ps and in to our input folder. So if I do ls in right now, it says I have a binary called ps. We are fuzzing read elf over here. So let's target read elf for now. So if I do read elf, right, it executes. It states that usage, read elf, and options with elf files, display information and file contents of elf file formats. Perfect. So this gave me an idea about that this binary takes ELF as a file format. And if we do file in and PS, you can see our input which we have been providing is a ELF file. Right? Perfect. Let's do read ELF hyphen, or let's do -h and in PS. Now -h is to get the headers of this ELF file. So if we hit enter, you can see it gives me the header of this PS file. So we are specifically targeting this attribute right now. It's read ELF -h in /PS. Just quickly checking, my audible is proper or still there is any lag?
It's okay. It's okay.
It's okay. It's okay.
Okay, thank you. Just let me know whether you are not able to hear me so I can repeat it, or whether I can do something else. And I'm really sorry for the trouble. But yeah, so we were at read ELF -h in /PS. So it gives me the header of this PS file. And right now we are going to fuzz read ELF, specifically enabling -h file, -h attribute. So our command would be afl -fuzz -I to input folder -o to output folder. We do read ELF -h @. Now guys, here is the interesting part. Previously, when we did wave info, we didn't specify any attribute, and we just randomly went ahead and gave @. Over here, read ELF requires certain attributes. So for example, when you do nmap, it requires -i capital L to pass the list of IP or the TXT file, right? So here's a quick information that if any crashes is being generated over here, you have to use this -h to replicate those crashes, right? And when we hit enter, it successfully works and it starts with fuzzing. So here we get 2,000 executions per second, which is fair enough. And the pending favorite path is 1 and total paths is 69. Perfect. So here is a quick exercise so that I can go back to the Slack channel. So if you guys are over here, and if you're guys with me, just go to your CD fuzzing. You have a folder called obutils _2.14. Just go to old binutils section. You have a tar file, just do tar xvf binutils to extract the data from the tar file, and go to binutils directory. So do the same activity in old binutils section using the same corpus which we used, which was fuzzing corpus, this one. And let's see what we get. Meanwhile, I'll have a look on a Slack channel. Just try fuzzing the old binutils with the same command, with the same steps. Okay, so there is a question that it says, how do you specify the portion to the file to use with the cmin? To the best of my knowledge, we cannot exactly specify the portion of the corpus or the input which has been passed. But for this, you can use a utility called half-empty, which has been made by Travis from Project Zero. So half-empty is capable of removing certain chunk data from the specific portion of the input file. So you can use that. Probably cmin won't be much helpful over here. You can use a tool called half-empty. You would be able to find it in the Tavizo's GitHub repository. Just Google for half-empty space GitHub, and I think it's fair enough. So that allows you specifically to remove the chunk or the data from the input file in the certain portions. Okay, fair enough. I'll also start doing with the same thing in the older version. So I'll do cc equals afl hyphen gcc, cxx equals afl hyphen g plus plus, configure, hit enter. So we configured it. Now we do make hyphen j4. I'm just doing it in the older version of binutils. The latest version of binutils has been fuzzed in my another terminal. It's 3 minutes almost, and I do make hyphen j4 in the older version. Meanwhile, if you have any questions, just let me know in Slack. You can do it the older version and the latest version both, because I want you to make sure that how you compare it, the results, how previously we used to get crashes or not. So it's fair enough. You can run both parallelly. Okay, so it says that there's some sort of error, but let's see whether we actually got the input which needs to be fuzzed. Okay, perfect. So we still got readelf. So you will get some of the errors which we can ignore it specifically. We'll go to binutils directory. Probably I'll stop this for now. Just do Control C. You can keep running if you want. I ran it for 4 minutes, 5 seconds. You can run it more than that. I'll go to binutils. Then what I can do is I can create mkdir in, mkdir out. I'll again copy the same corpus which was PS in input directory, same corpus, there is nothing changed. So I have the same corpus and afl hyphen fuzz hyphen I input hyphen O output, do readelf hyphen h at the rate and hit enter. Right, so it started the fuzzer, and you can see we initially got one unique crash, and there are 5 altogether crash, but 1 unique. Okay, so there's a question. Can you copy the last CC options to compile? Okay. So this was just to give you idea that this binutils was created back in 2016, or it was a version of 2011. You see, we started fuzzing, and initially it gave us 1 unique crash. But this is the latest version of binutils. We ran it for 4 minutes and there was no crash. And let's see if we ran it this for 4 minutes, what would be the ideal case over here. Yeah, so there's a question which says that if we specifically pick any application in C, then create a make file and then fuzz it, is it exposed to a bug? So let me clear here, not all crashes might be a bug, because until unless you, like technically, if we cannot overwrite the EIP or RIP, it's just a DOS, or maybe it's just a normal seg fault or a crash. So you can just simply submit those crashes to GitHub repository so that at least they can patch it. So probably not all crashes would be a appropriate bug. Okay, so I think we are also running out of time. So you can keep this running for 4 or 5 minutes parallelly. I'll stop this over here just to give you an idea. So we ran it for 2 minutes, 9 seconds. We got 1 crash. Over here, we ran it for 4 minutes, 5 seconds, we got 0 crashes. So you can see how we explored the era of fuzzing. Now, binutils is part of OSS Fuzz, which is being run by Google. So they keep fuzzing binutils 24/7. And if any crashes are generated, it goes to the maintainers or the developers who are maintaining binutils. So here's the pro tip. What you can do is the crash which was generated in the older version, you can take this crash, this specific crash, and you can simply do like, let me do it out crashes. You can do mv id2 poc. So the crash which was generating, you can use this specifically as an input to pass in the latest file. So this is one of not a pro tip, but a juicy information. Like you can fuzz the older versions of binaries, get and extract all the crashes, and use those crashes as an input, and fuzz the latest version or the master version or the main branch version of the application or the software. So that will also help you to generate crashes very quickly. Okay, so there would be the list of commands again in the slide, so nothing to be worried. Moving on, we have fuzzgoat as well. Now, fuzzgoat is one of the software which has been written by some person. It's a vulnerable C program which you can use for fuzzing. So you can get your hands dirty over here. It's again in the fuzzing folder in C fuzzgoat. Right? So I'm not going to this because it's very common, very straightforward. You have makefile, but if you have any questions regarding this, just get back to me on Slack. So it's just to give you an idea that you can, it's just an FYI. So you can use fuzzgoat. It has different types of bugs, start from use after free, buffer overflow, read after write, and etc. So more targets over here. What will be the more targets? So most of the people are like, what should be fuzzed? What all are the common open source, what you can say, utilities out there which can be fuzzed? So you can use you can fuzz OpenSSL, you can fuzz libpng, you can fuzz PHP, you have OpenJPG, you have COL, you have ItterCap, WebKit, MySQL, and there are tons of other different softwares in GitHub repository out there to fuzz. But you can understand, right? If you get any exploitable vulnerability in PHP, that would have a huge impact on the attack, what you can say, surface. So you can start running fuzzer on PHP with certain commands to see how it fuzz. Perfect. Just to quickly take this, I'm not sure. Okay, so I have a server. This is just a bonus slide, like a bonus quick session for you guys. So I have a server. I have created a Vim corpus POC file. So it has some random chunk data in Vim. And what I can do is I can git clone https github.com/vim/vim.git. I'm cloning the main branch of Vim right now, the stable version or the latest version of Vim. What I can do is now, once it is git cloned, you can, it's not necessary that you do this. It is not available in your slides or anywhere in your Ubuntu OS. This is just to give you a general idea that I have something for you guys. Like I have a mutated corpus right now, and I am using the latest version of Vim. So I just go to Vim folder. I have a configure file, so I'll use cc =afl-clang. I can use Clang or GCC, it's up to me. I can use Clang-fast. CXX is afl-clang-fast ++ to configure, right? So we will do configure. It will create a make file for us. So again, guys, you don't need to do this. It's just to give you an idea that how when you start with fuzzing, everything depends upon the corpus which you are using. So all the game lies in the corpus file, the input, which is. Just rechecking, am I audible properly?
Yes, yes.
Okay, thank you. So once we have created the configure file, we go ahead and we do make-j4. Now Vim is again one of the complex program. So it will take a little bit of time to configure. So just make sure, if you can see on the left-hand side, it instruments the binary. Just make sure when you do it, you are specifically instrumenting it. You are using the cross compiler, which has been provided by AFL, AFL Clang, AFL GCC, and so on and so forth. We use make-j4. J4 stands for number of threads. It can be 10, 12, depending upon your course which you have provided. Perfect. So we have created a Vim. If we go to SRC, right, we have a Vim binary over here, right? So I'll do mkdir in, mkdir out. I'll copy the Vim underscore corpus POC to the input directory, right? Now there is, whenever you fuzz, if you have a server or something, don't fuzz in your main terminal, because if in case there is a glitch on internet, maybe the SSH pipe would be broken and again, everything is being lost. So it's better to use a utility called screen. You can go to screen, and I'm in screen inside right now, which similarly look like the terminal. So if I do Control A 0, so it says that this is a window 0, like I'm on window number 0. So now I can do AFL fuzz -I input -O output Vim. Now I have figured out personally that there are certain set of commands which can allow you, like -u none. It means that no GUI, like there should be no GUI when we run this. -e small s capital S @ -CQA. I'm not sure if you can see it, but it's like AFL -fuzz -I in -O out Vim -u none -e -s capital S @ -CQA, right? So I'll simply run this and it will start fuzzing. So now I am in screen. So what I can do is Control A and D will take me out of the screen. So I'm just pressing that. I'll just keep running this. Meanwhile, we'll continue with our session and we'll do Control A, D. I'm out of the screen right now. So it created a screen called 18547. So it's screen -R to resume on 18547. Right? So I'm back in screen again. So you can see the stability went down to 80% because Vim is one of the complex program, but it's fair enough. And the execution speed is 300 inputs per second, which is also fair enough. So let's do Control LD and that's it. Let's exit from my server. Perfect. So we'll see the results, whether do we have any crashes back there or not. But moving on, you can similarly fuzz more targets, such as you can do apt-source. You can have a list of Ubuntu packages which are available. You can fuzz all those. Like for example, if libwave-api.poll takes any of the input file, you can fuzz it. So it's not like you don't have targets to fuzz. There are a lot huge surface out there to fuzz open source or common binaries or software. So here are some pro tip, like if you found that there are some packages or some header files are missing, you can use apt cache search with package name, like over here apt cache lib GTK, you will find out the list of packages, you can install it. If you compile any program which gives you error that this specific header file is missing, you can use apt-file search with file name.h. It will give you, and it will generally give you an idea about which package contains this header file. And obviously I demonstrated how screen works. It's fair enough. You will find it in the manual as well. Moving on, there's another topic. We are also running out of time, like there's very less time remaining, but I'll try to cover everything. Now, this is a very, very great utility. It is called Sanitizers, which has been maintained by Google. There are not two, but more than that, but the commonly used are address sanitizer and memory sanitizer. Now, AFL, it runs, and basically you have to pass an input, it generates and mutates the input and then generate the crashes. Now, address sanitizer is capable of detecting bugs during the runtime itself. So if you have any vulnerability and during the compilation itself, if you have enabled address sanitizers, it will basically give you the stack trace, or will give you an idea whether there is any overflow, whether there is an UF or not. It's very, very helpful for CTF players out there and for the developers who are developing their C program or etc. So address sanitizers, also known as ASAN, is capable of detecting few of the bugs which I have listed here. It's UF, heap overflow, global buffer overflow, stack, use after return, or any sort of initialized or uninitialized order bugs. So we'll just quickly have a look on this. Similarly, we have memory sanitizers, also known as MSAN. Now what happens is when there is any memory leak in a program during the compilation, MSAN is capable of detecting those traces. The alternative of ASAN and MSAN would be Valgrind, which I personally don't like it, but you feel free to test those utilities on your software or on your first application. So yeah, that's how it looks like. Let's go back to the VM. Let's go to the fuzzing folder. Let's go to fuzzing folder. Let's go to overflow. We have buffer.cc, right? So let's do cat buffer.cc. It's a simple C program. So you can see it has a buffer defined with 20. Now we all know, like it's a very plain vanilla buffer overflow. So when we do GCC buffer.c-o buffer, we get file generated. It says enter some text. I entered AAAA, hit enter. Now this character was more than 20, so that's why it says that stack smashing detected and aborted, right? So there's a stack-based overflow or a buffer overflow over here because we are passing it more than 20 characters. But how ASAN will help you over here? Like, let's just remove RM buffer. Now let's do GCC -f sanitize equals address buffer.c-o buffer. Oh, okay. So there's a typo. Let's copy this so that we don't miss anything. GCC. You don't have to use AFL over here. It's a complete different topic. GCC-f sanitize equals address, because we have to use address sanitizer. You can use memory as well, but let's not use it for now. We can use buffer.c-o buffer. Perfect, right? So if now I do buffer and hit and enter some character which is more than 20, you can see it gives me a proper detailed traces of the heap or the free stack or the common EIPs which are available over here. So now this file which we used is a very common buffer overflow scenario. But if you use this in any of your CTF, like there's a CTF called Pico CTF, PICO, Pico CTF, you can just Google for this, and you will find in a GitHub repository set of binary files, which doesn't generally give you details like this. They will simply say like, oh, okay, stack smashing was detected and that's it. But if you enable sanitizers, it will give you whether it was a stack overflow or a heap or memory leak or use after fee or etc. So this gives you a detailed idea about the stacks and the specific pointers or registers where it was being getting crashed. So it detects the bug during the runtime. So when I hit enter AAA, it found out the error and then it executed the program, right? So that's how sanitizers are helpful. So if you write any C program, you just compile it and see whether you have any traces or not. So that's how we use sanitizers. So this is just to give you an idea. If you have an executable, when I mean executable, it's a wave info or which we first, it's a vim or so on and so forth with ASAN enable and library with ASAN enable. Now let me clear what library is. Now let's suppose, just to give you a general idea, I cannot think of any example right now. So there is a PDF called XPDF, which is one of the most common library used by the common widely PDF render software, like Poplar, PPLER. It's one of the most common utility which comes with your Ubuntu and Debian. Now they used a library called XPDF. So if you have an executable and a library both with ASAN, you can fuzz it. It works perfectly. If you have an executable compiled with ASAN, but library compiled with no ASAN, still it works. But if you have executable with non-ASAN compilation and library with ASAN, you won't be able to fuzz it. The reason being because libraries are just supporting files which basically helps to run or spin up the fuzzer. But over here, when you only support ASAN to libraries, not to executables, they are not specifically compatible to share their libraries to the actual executable. And that's the reason we are not able to fuzz it. So whenever you fuzz, just make sure that you have executable and library both with ASAN or whether both without ASAN, and it will work perfectly. Again, this is a FYI. There is a thing called LLVM symbolizer, which comes with Clang. You can just navigate to this website when I share the PDF, or you can just simply Google for LLVM symbolizer. Over here, when you see, it just gives you SO file. It doesn't give you at what line number it was getting crashed or what was the function which was responsible. But when you enable LLVM symbolizers, it is capable of finding the file names and line numbers specifically. It's pretty common and straightforward, but if you have any doubt on LLVM symbolizer, we can take this on Slack post workshop. Okay, what happens when we have AFL plus ASAN? Whoa, so when we make it together, this is how the command looks like. It's like cc equals afl-clang fast, or it can be gcc or g++, it doesn't matter. And that's how you enable ASN underscore options dot symbolize equals 1 and AFL underscore use underscore ASAN equals 1. Now 1 stands for enabling it and 0 stands for disabling of ASAN. So whatever command we used back in the binutils, like for example, over here, cc equals afl, you can simply use this command. If you want to enable ASAN to your compilation while fuzzing. Oh, okay, my bad. Just to make clean first. Make this clean. Now we are cleaning it because we have already created certain set of chunk data. Now if we do this and hit enter, oh, okay, I haven't used configure, right? So over here, you can say the difference. It says instrumented at one location with ASAN and MSAN mode. Now, you would be wondering that we have only used ASAN. Now, the problem is when we import ASAN, we get MSAN by default. So you can exclude it, but I think it's pretty much fair enough to have both of them. So in previous fuzzing instance, if you see when we compiled it, it only said as like instrumented non-hardened mode ratio 100%. But over here, when we instrumented this, or basically when we run configured, it says ASAN and MSAN mode enable. So that's the reason we are using this. Perfect. So you can have your hands dirty on this, but I would like to move further. Similarly, you can use AFL use underscore MSAN equals 1 to call MSAN, but as I've said previously, like in ASAN itself, you get both the options. So that's fair enough. Okay, so when you enable ASAN, it requires more memory. So here, when you do AFL fuzz, -I in -O out, and let's suppose we were fuzzing read ELF -H at the rate. When you do this, now AFL by default takes 64 KBs of memory of fuzzing. So when you enable ASAN, it will give you crashes, but it would be OOM, which is known as out of memory. So it's better to have -M none option. So that means that you utilized your memory to the fullest when you enable ASAN. So this is the additional command which you can add, or else you will generate crashes, but it would be out of memory, OOM. Perfect. Just checking again, is my audio perfectly working fine?
Yes.
Yes.
Okay.
I think that maybe because you turn off your camera, you don't need that much internet, so it's working pretty well now.
Okay, perfect. So moving on, we already covered AFL. We covered AFL compilation. We had a look on CMIN. We had a look on fuzzers. We checked that the difference between the binutils of the older version and the latest version. We had a look on ASAN, address sanitizers. We had a look on memory sanitizers. The next topic is pretty much interesting. It's protocol fuzzing, but we won't be using AFL over here. Probably we can use AFL to fuzz protocols, but it's again a huge 2 to 3 hours of workshop. But just let's quickly have a look how we can fuzz protocols in a very easy way. So I personally like two utilities out there, which is known as Duna and Bufuzz. Now, Duna is written in Perl, and Bufuzz is a pip library which you can use in Python, pip3 install Bufuzz or pip install Bufuzz. So they both are capable of fuzzing network-based protocols such as HTTP, SMTP, FTP, IMAP, UDP, and so on and so forth. Like most of the common network protocols can be fuzzed in this. So how do we use it? Like the Bufuzz, I have a write-up which I can share it, but let's have a look on Duna first. We have Perl duna.pl -m HTTP, then the IP and the port. Now let's go back to our terminal. Right, we have already Duna installed, right? So what you can do is, let's open a new terminal, new window, and we run Python -m simple HTTP server, right? So it's running on port, like port 8000. I'll just minimize this so that it is visible properly side by side. Yeah. Okay, so what we have to do is Duna -m, the module -m, whether we are fuzzing HTTP or HTTPS. Now by default, Python simple HT server uses HTTP protocol. So we will use HTTP, then -t for target, which is my own. It's like loopback address 127.0.0.1, -p for port 8000. And that's it. So if we do hit enter, you can see it starts fuzzing this specific protocol. It sends certain set of multiple A. It will send certain chunk value, certain data. It will change your post method. It will change the methods to head, delete, put, and so on and so forth. So you can see how it starts fuzzing. So if you see the code over here of Duna, you can see like the overflow string starts with the byte A into 33, then it moves to A into 254, then A to 255, 256, 257, and it goes on. Similarly, in format string, it starts with %s into 4, then %sp, and then it move on. So if you have a look on the code of Duna, so if you go down more, like I have a screenshot currently right now. So in a sophisticated attacks, it starts with the changing of the methods, the post method, the head method. It adds the put method and so on and so forth. Right. So now Python simple HTTP server, you can see it says pipe broken, request callback. Maybe, I'm not sure, I have never left this running. Maybe it might be capable of generating any, it may send certain malformed GET request which crashes this Python simple HTTP server. I'm not sure because I have never done it. Similarly, let's have a look on something else. So that's what we had a look on the example. Now we have fuzzing Mozilla PDF.js. I'll stop this for a while. Let's go to CD PDF. Okay, it's in my fuzzing folder, PDF.js. Now PDF.js, guys, this is one of the rendering what you can say component which is being used. So whenever you open a PDF file in Mozilla or Firefox, PDF.js is responsible to render this. Now in my research, I figured out that there was some crashes which I found out using Boofers, but similarly you can do it for Duna as well. So you have to just go to fuzzing PDF.js and you have to do gulp start or gulp server. Okay. And oh, sorry, SCRVER server, right? So it says it is running on localhost 8888, right? So guys, let's do it on 8888. I hope you guys are with me. When I run this, you would have seen one thing over here, that there's no traces being generated over here. Now, this is one of the drawback of the tool called Duna. Now in Python simple HTTP server, we were able to see this because they have a callback functionality and it gives the traces to you. But in few of the servers, you won't find it. Now, how do we see whether it is actually fuzzing or not? You have to go to old school. You can just simply open Wireshark and see it on your loopback address. Just capture the packets. See, right? If you see, you can just do follow TCP stream. Okay, this was some bad packet. So the idea is you can keep a track using Wireshark. Okay, this is still not which we are looking at. So you will find the same output which we were able to see previously. Let's capture some other data. Okay, so here it says that it sends this as a parameter and it receives 400 bad requests, right? So I know it's a hard job. Like if we found any crash, I have to go to this entire packet and to see whether which protocol was being used and what is responsible for that. but seriously, I haven't found out any other way so far yet. So what happened is, but when I ran this for a couple of days, I figured out that there is a command, like it causes a crash to fuzzing pdf.js when we pass col-i http:/localhost port 8888 slash with percentages. When we hit enter, the pdf.js is not able to decode the specific URI, and because of that, the server of pdf.js get crashes. Now, I had a very hard time to figure out which URL or which specific string was basically crashing this, because I was just simply fuzzing it, and I ran the Wireshark for entire 3-4 days, and then went to each and every packet, filtering out using Wireshark command. And at the end, I figured out that %s is actually crashing the pdf.js server. Now, this pdf.js server is obviously the vulnerable version. So when I found this, I submitted to the Mozilla team. So they patched it. Now they have, like, if they find out any any headers which has a bad request, basically it gives you like it gives the 4 of 4 error. So I'll just take a moment over here to have a look on a Slack. If you have any questions, let me know. Okay, so why don't I like Valgrind? Because I personally don't like it, although it's a very, very awesome tool. But you know, address sanitizers give more specific and more detailed stack traces or the crash traces, which I personally don't found to be useful in Valgrind. So that's the thing, I don't use it. Yeah, so we can use Duna for that. If you have a custom, there's a question in Slack which says that if you want to fuzz any custom TCP or UDP messages, you can use Duna. We don't require any source code. Now let's suppose that if we just simply running gulp server and we don't know the source code of this, you start running Duna on that. And to see whether, if it's a custom in-house application, for sure, if it is not able to decode or handle any malform packets, for sure we will get crashes. So we don't require a source code to fuzz HTTP, UDP, or SMTP protocol using Duna. So that's very straightforward. If you have any questions, you can buzz me on Slack. If you are doing anything, whether it's related to AFL or ASAN or Duna, just please feel free to buzz me on Slack. I haven't researched anything for Unix yet, but definitely I can sort something for this and I can get back. Apparently, I don't have any other utility for Unix, but just give me some time. I may be able to find something for this. Perfect. Is there any way to fuzz Python program? Yes, there are ways to fuzz Python programs as well. So AFL is one of the frameworks. Similarly, we have different other frameworks which can help you to fuzz Python programs. I have listed few of the frameworks which are capable of fuzzing Python programs. You can just navigate to those and have a look. It's pretty much straightforward. So you can just simply have a look. Okay, so moving on, this is the idea, like how I can approach this as part of my bug bounty programs. So whatever we have learned so far, how we can utilize this as part of our bug bounty to find bugs or to get payouts and so on and so forth. So if you go to hackerone.com node.js.ecosystem, HackerOne specifically have Node.js in the bounty program. Apparently, they don't give dollars, but they do have reputations which can help you to get more private programs. So there are Node.js HTTP server, simple HTTP server, serve, and 2 more. which you can emulate or spin up in your terminal, and you can fuzz them using Duna. So that's how you can leverage this in your bug bounty or HackerOne program, specifically Duna. So here are some of my research, which I figured out when I started with fuzzing almost a few years back. I haven't updated it yet though, but these are a few of my cool, or you can say the awesome one, which I have figured out. So I fuzzed the WebKit. The blog is on the description, not description basically, but on the slide. What we figured out that when I was fuzzing WebKit, when we do alert in WebKit, another pop-up has been arrived. And if the pop-up size or the character of A is more than 5,000, the WebKit crashes. So CV 2019-8375 was observed. It was assigned basically. It was a denial of service vulnerability, and the WebKit team patched it. So if you want to know how I went with all the fuzzing approach, it's over here. I can share the details. You can have a look. We will be connected on Slack. We can have a chit chat on that. I also fuzzed Wolf SSL. Now, Wolf SSL is again one of the SSL library and protocol which is being used in most of the IoT devices out there. So I found out a heap-based buffer overflow when you send more than 16 KB of test packets. Now, apparently, I found this in their test folder or the test segmentation. It was not affecting the actual Wolf SSL, but there was a lot of efforts required to capture the handshake and then fuzz it. But still, this was patched because apparently it's still a bug in their test program. So you can see the pull request which passed this issue. I also fuzzed a getlib. I found out a stack-based buffer overflow. Now this is pretty much simple. There was a discover binary, used Python C, print A to 20, and there was a segmentation fault. And I used ASAN to discover that this is a stack overflow. Again, this was reported as part of the getlib project, and it was patched. CV 2019-6498 was being submitted to this. There were certain memory leaks which I found out during the Putty bug bounty program, and they rewarded few dollars. Now, again, this was done by fuzzing the Putty binaries or the Putty ELF files. So the agenda of this to showcase is like you can, whatever we have been learning from past 2 hours, you can emulate this in your environment or in any bug bounty programs. So you can have a proper deep down research into actual programs, which now you can get an idea, right? The Putty version has a memory leak. So it has a big attack surface. So you can have the similar programs like PHP, Apache, and so on and so forth. So yeah, that's what the idea was, fuzzing plus IBB. Now IBB stands for Internet Bug Bounty Program. So if you go to HackerOne directory and apply the below filter IBB and select the active program, you will find out there are few programs which gives you the ability to submit crashes or traces and to earn the dollars or whatsoever the bounty amount is. So you can use all those in whatever we have learned, you can use that. Or if you go to this directory, you can have a look on their activity panel to see the previous people, what they have discovered.
Dhiraj?
Yeah.
We are only having 10 minutes left.
Yeah, that's
so
almost done. Yeah.
Okay, so you have the time.
Okay, no problem. So more fuzzers ahead. We have WinAFL, not just AFL. We have WinAFL, HongFuzz, Kitty, Sully's, ClusterFuzz, and Fuzzily. You can use all this, and specifically Sully is something which it can help you to fuzz Python-based programs. So yeah, that's what. And before wrapping this up, let's quickly have a look whether we found any crashes in the Vim which we were fuzzing. So if I do AFL-got CPU, so it was just using a single core. And if we do screen, no, we still haven't received any crashes yet. It's just 31 minutes. Maybe I can give you a quick update on the Slack itself if we receive any crash. So just quit this up. No problem. Okay. So that's all from my side. Thank you very much for having me. And I'm really sorry if you have a connectivity trouble in between, but if you have any questions, just tweet me on random Dhiraj, or you can send me an email at dhiraj@inputzero.io, or alternative would be the Slack channel, which I have created. We can be in touch and we can have fuzzing sessions like this. Thank you, Ekoparty, for hosting me, and thank you for bearing with me. So that's all from my side. Thank you very much.